can add or edit restraint in Tekla Structural Designer. You can come back and check in the document. We will use the last method to edit restraint by using set restraint. Okay, now let's come back and we use this method because we has raster and purlin connect each other at the top. So the method we can use when we has a beam intersect with other beam or other elements. Now let's click on the saw alter stage, change from the material, scroll down, find the restraint. Where is restraint? Yes, restraint. And to review and the and check the review. This is the top. The raster has the restraint at the top only, not at the bottom. So now let's check with the strut. No. Okay. Now come back. We use mode, change it to set. We want to set the restraint type restraint at the top or bottom of the raster. Okay, let's set. Because at the bottom we will add lateral torsional restraint to prevent lateral torsional buckling on the raster. Now let's set it all. Again, set it all by use window select. Okay, now complete. Control S to seal and come back to design. Click on design all static. Okay, now this member pass, the ratio is 0.8, 0.8, 0.8, 0.8 and 0.8. It's okay right now. It's okay. And beyond the scope. Why it beyond scope? Maybe this section resist torsion. So let's check it. Right click. Check member, open, torsion, yes, right now it is a torsion beyond scope. Okay, deflection is okay, deflection impulse is okay, for the deflection is okay, and come back to check the result. Review and check the ratio. Yes, now we can fit the raster by add lateral torsional restraint at the bottom. At the bottom, connect with the purlin. And this is how we can fit the element file at restraint. Now the element, the raster pass. Everyone, welcome back to premium course still for whole design. After we complete analysis and design and fit the raster and column, we use method to fit column by edit property. So now I will show you another method to correct restraint on column by using method set restraint. Okay, click on saw alter stage and scroll down to the restraints and change the entity types to columns and review. Now check the lateral type restraint type lateral. This is the color phase A and phase A and phase C. You can check more detail and support document about which one is the phase A and phase C. Yes, for A, you show the direction of beam. This is the phase A, and opposite flank is the phase C. Yeah. How you know about phase A and phase C? By show the direction of beam. Now let me come back to Tekla Structural Designer. Yeah, this is the direction of the columns. So the outside flank is the phase A. Okay. Now you can set the restraint. You change it to set, and the restraint type, change it to the restraint, and restraint. Click on the phase A and select the restraint in the girts intersect with the columns. Yeah, in the position, select it, and in the position, select it to set. And for the right column, also the same. Phase A, yeah, phase A, change it. Okay, and again change phase A to phase A and phase C, and select for the location because we want to add restraint. Okay, select and select. Change the restraint to strut, and change the restraint type to measure and minor, and set restraint at the location. Okay. How you can correct the restraint in column? By using the set method. For more detail, you can read my support documents on the section columns. Lateral torsional buckling restraint on columns. For column design using the zero code, the LTB design length is assumed to be between those positions where the column is restrained in both the measure and minor compression buckling direction at plane A and C. So why we had to add restraint on the measure and minor C? Because we want to add the lateral torsional restraint on the column. Yes, LTB. We add the restraint in both measure and minor compression buckling direction and at the plane A and C. This is because the interaction questions given in the zero code only cover the design between point of full restraint in both directions. It is a very important note in Tekla Structural Designer. Again, come back and click on design. Click on design or static to run analysis and design again. Yes. Now let me check why it failed. Maybe because we changed the direction of the top and bottom. Now we had to correct it by using view and author restraint, change it to the beam. Okay, it's correct right now. Lateral, yes. Now we have to set it again by clicking on this intersection point. We add the torsional restraint on the bottom of the beam. Okay, save it, come back to design, analysis and design static. Seal the models and check, yeah, it pass. Now check at the middle column by right click and check static and check for the lateral torsional buckling. The length LTB is equal to 1.5 meter. So we had to add the lateral torsional restraint at the intersection the purlin with the bottom plane of the column. I will show you later about how we can add the restraint to the purlin and to the column. Use the same. The best location to add restraint, we add at the top, at the maximum bending moment, and for the column also we add the torsional restraint at the tension phase. Okay, tension phase of the member. So for this raster, at the intersection with the column, the maximum tension moment at the top, so you must add restraint to connect from the purlin into the bottom of the flank, and other side we do the same to add restraint at the compression plane. For the location in the compression plane, it's no matter to add the torsional restraint, but other side for the tension plane we must to add it again. You can check it in the analysis result for more detail. For the measure and change it to the local envelope. Yes, this is the way you know how to add restraint on the beam and on the column by checking the envelope force moment. This tension force, yeah, tension moment, tension phase at the top of the flank, and this one tension at the bottom of the flank. So the top flank in compression. In compression, we can add the restraint, torsional restraint in the location, and for the location you can add at the intersection. It's a noise, but in my design code I add it all intersection of the purlin with the raster. For the column it's the same, we add it the maximum moment in the location and in the location, so you can add torsional restraint. It's a noise for the location you can add or not, it depends on you to verify and check it. And for the raster it's the same. I saw in support document how you can add restraint on the side rail or on the purlin. We use the same concept on the column and raster, connect from the purlin or side rail into the bottom plane to prevent the lateral buckling of column and of the beams. And this is the yes, this beam we connect from the top of column to top of column each other to make stability of the out of frame or frame. And this is the location, the best location to add the torsional restraint. We should add it in the location and in the location. And for the column, we also add at the top of the column, yeah, to prevent torsional buckling of the column and of the raster. This is the best location to apply the torsional restraint. Yes, torsional restraint in the compression plane and in the tension plane. In the tension plane, you must to add torsional restraint, yeah, torsional restraint. And compression plane, you can check if it not required. You do not need to add the torsional restraint. But in the practice, you should add it at the end of the raster in the location. At least this is the tension plane. You should add the full restraint. Yeah, the full torsional restraint. Yeah, torsional restraint. Thank you for your watching. I hope you enjoyed the tutorial. For more details, ask me in the group. Thank you.